Oh, shoot. Alright. Blanket. Hey, oh, sorry. Wait. Anybody else not get their quiz back yet? Everybody got their quiz back? Okay, so let's do this. I want to finish this first. I think this is a little further than we got last time.
Yeah.
I lost my copy, so I try to catch back up to where we were. I want to kind of quickly remind you how we did this. And let me know again, let me know if you don't have this sheet. So we put these, what did we do with this data?
Put it in the
List.
calculator.
Put it into list one. So there it is, and then we sorted it, yes? And sorting, we should all be cool with that. How did let me clear this. We got the mean to be 6.5, yes? Okay. I want this row to be x minus x bar. No, again, if I ask you, calculate the standard deviation, you're gonna have this formula on your formula sheet, right? So let me get a clean, but I need you to understand, we're gonna have several formulas throughout the semester that have this symbol in it. What does this symbol again mean? Sum. If you cover it, you find out what you need a column of, so then you're freaking able to add them up. I can't add the shit up until I get them. You guys would, because one thing I want you to realize, I'm not gonna label these columns. I'm gonna give you a blank table, and you have to know how to build it, yes? But how does a formula tell you what to do? I eventually wanna have a bunch of these. So first I can make x minus x bar, and then I can just square those, yes?
Yeah.
I've shown you how to do it in the lists in your calculator. If you feel really uncomfortable with that, you don't need to. You can do each row by hand. It'll take a little more time, but you can still do it, yes? Okay, because I got people that are like, they left it blank, they turned it in, it's, I didn't know how to use it. I'm like, you could just do it, just do it, it's okay. So here I am in the calculator. How do I make list 2 do what I want it to? Yeah, go up to list 2. And I want it to be all the x's minus the mean. And where are all the x's?
List one.
List 1. So I want it to be list 1, because that's all the x's, minus 6.5. Will it always be 6.5? No. Why is it 6.5 here? Darn it, Jeff. It works over here, buddy. Because that was the mean for this case, yes? Sort of like, you with me?
And then it answers, it'll do all
You ready?
of it. It'll answer all.
Shaboom!
Shut up, that's what.
No, I won't shut up. Because then, the class, there wouldn't be any point. Sorry. How much does this calculator cost? Anybody buy this calculator?
Mm-hmm.
How much did it cost?
100.
100 something, that's all you gotta say. It better frickin' be able to do subtraction. Holy shit. So this is Excel, just a little worse, yes? This is Excel, just a little worse. It just is. But it's mobile Excel, so that's good. Okay, is everybody with me? And again, you could just do 2 minus 6.5. You could do each row, that's fine. And then square what you get, that's fine. If you're like freaking out on the test, you could just do that. What do I want list 3 to be?
List 2 squared.
Yeah, I want it to be all these things squared, and these things are list 2. So I want it to be list 2. See how I have L3 highlighted?
Yeah.
So I'm going to define L3. I want L3 to be all the stuff in list 2. List 2 is above 2, yes? I want list 2, and I want to square those things. Chapow, yes? Can you stop? On a test or a quiz, I need you to copy those down. I'm going to give you the table, you just got to fill it in, yes? Okay, yes?
So to do that right, you go to list, you highlight the list, and then what do you press to like enter L2?
So if you go up to L3, See how at the bottom it says L3 equals?
Yeah.
Okay. L2 is right there. So hit second 2. So now it's gonna set it L2. And I want L3 to be L2 squared.
Got it. Okay. Thank you.
You're welcome. So you can define a list to be any function of other lists. I could define list 4 to be list 2 plus list 3. Do you see what I mean? And later this semester we'll be doing more stuff with these, yes?
If you change the list that it's dependent on, does it update live?
Nope, that's why I said it's Excel just works. So if you change something, if you mistyped like if that's 2 was supposed to be a 3, watch this. If I go change that 2 right now, watch the first row. 3, they didn't care. Yeah, so this is not live updating data. Because then it would have taken a chunk of your battery and it would have cost $300. So, yes.
So I'm not gonna lie, I lost a little bit. What have you got from that point to this point?
Alright, let me do
Because I was trying to clear them because I was like, I had to clear a bunch of crap.
No worries.
I had to plug in all the data points again.
Here we go. I'll do it over again. All your data's in. You don't have to sort it, but sorting's a good idea. Highlight list 2.
Okay.
And I want list 2 in this case to be the distance my data point is from the mean, yes? So I'm gonna do, where are my x's? Where are my data values?
Your data values are
Where are they in the calculator?
in L1.
L1, so I want L2 to be L1, that's my x's, minus
Minus.
the mean of the data, which in this case is 6.5.
Minus.
Sorry, let me do
In the mean.
L1 minus 6.5, because that's the mean in this case.
Okay, so.
Bam! Shit!
Squiggly U.
Oh, this is good. Okay, this is
So
perfect.
the mean is the squiggly U thing, right?
No, hold on. Is this a population
Yeah.
or a sample?
Sample.
Sample. Why is it a sample?
It says in the.
So that's sample. If it doesn't say, if you're like, I can't tell, that means it's a sample. If I'm a statistician and I have a whole population of data, I'm almost giddy. I want to go up to the rooftop. I got the whole population. So in the problem, if it's a population, they are going to make it clear. If you're reading, you're like, is this a sample? It's a sample. It's a sample. It just is, because that's what we almost always have. Does that make sense? Yes.
So the only difference. Never mind.
Real quick.
They go over it.
Do you see the error I have on screen?
Yeah.
Because I was trying to clear and all this. What I did was, if I go to, I try to put an entire list into one spot. You see that? Okay. So if I go up to list 2, I want it to be list 1 minus 6.5, and then I want list 3 to be those things squared. Why did we have to square those?
So they're not negative.
So they're not negative, so they don't cancel everybody out. And we don't make everything in the universe 0 and then go back in our case. So I want L2 squared. I love it.
L4, L3 square rooted.
That would just bring it back to L2 without negative, so yeah, no. What do I want to do now? What's my formula say that it needs? It needs the what? Sum of these. Where are these? Where are they? They're in list 3, correct? We built the damn table. List 3 has these guys, yes? So which list do I want to sum and put the number here? List 3. So I want to do something to my list, correct? Do you see above stat where it says list?
Yeah.
Okay, so let's get out of here. Second mode to quit. Get out of your list. Second stat to get to the lists. Yes? I want to do math to a list, correct? What did we just say we wanted to do to the list?
Math.
Sum. The math, we're there.
Oh, cool.
We want to specifically do the sum. What do we want to sum up? List 3.
Can you go back like about to
Yeah, here we go. So second stat to get to list. Because why does it make sense I want to go there? Because right now I want to do something to a list. So let me go to the place where it says list. Go to math. I I wanna sum up, so you can either highlight 5 or you just hit the number 5. I wanna sum up second 3, L3.
So it just does it individually?
How do you mean?
Cause it only changed one thing to 69. Did it change the whole list?
If you, does it currently say 69?
Yeah.
Okay, so, put 20.25 back in there. Okay. If I don't, so right now, I'm in list 3, the first position, yes? If I just start typing stuff, it's gonna put the answer here. Do I wanna change my list? So that's why you have to get out of here first before you tell it to do anything else. If I tell it to do something right now, it's gonna put that answer there. So I gotta get out of my list. Second, quit. This is a very important button. If you accidentally hit something, you're like, what the shit? Just hit second, quit. It takes you back to the nice home screen, yes?
So,
Okay.
so it should look like that.
Yeah, it looks better. Now go to stat. Sorry. Second stat, go to list. Math. Sum. And you don't have to go down, you can just hit the number 5. Sum up L3. Now very quickly. If on a test that you could have in the future, you get a little flustered and you forget how to do what we just said, just add these up, yeah? Just 20.25 plus, you know, just take a deep breath, you're okay. You're just not gonna do the shortcut, but you can still get the answer correct. What I'm showing you with the list, math, sum, it's a little shortcut. Or you just add the damn numbers, yes. You always can do it directly. Because I'm never gonna give you like a list of 80 data points.
What did it say to, like, after you add them all, cause I got 69, right? So they go.
Oh, we haven't done anything else yet. That's all we've done. Okay. Yes.
So I tried to do it on my calculator, just to make sure I know how to do it without your help. But I got this completely different, so I think that's a great something.
Oh, well, show me what you did. Oh, line 12.
That's why I drew it on the cup.
What's this? Which is the mean. Yeah. Good. So guys, let me ask you this. Can somebody tell me what standard deviation measures?
The distance between two data points.
Almost, not quite.
How many steps?
Sort of.
How far from the mean?
How far what's from the mean?
Next step.
Oh, how big your step is?
No, the standard deviation is how big the step is, but what does it measure?
How many steps you have to take?
Okay, here's what it measures. And this explains why the formula is the way it is. Standard deviation measures the average distance from the mean to the data points. That's why we did everything we did to get the formula, yes? Standard deviation measures the average distance from the mean to all the data points. Now if you think about that for a moment, that just naturally makes sense that it's the spread. If my data points got further away from the mean, doesn't that mean my data is more spread out? So if I do an average distance to them, I'll get a bigger number, yes? So we made a choice. There were choices we could have made. We could have defined it differently, but this is the one that made the most sense. I have a mean. That is the most important kind of measure of center because it doesn't leave any data points out. It includes all of them. The median didn't give a shit about any of them. It just says, what's the middle? So that's why it kind of wins out. And then I want to base my spread on that important number. How far from the middle do I get? So, yeah.
On either side.
Yeah, totally. And that's why some of the things were negative, because those were below. And then I had to square to kill those negatives. Yes, okay, maybe. How much do you have to know what I just said to be able to do this problem? Not. How much, if you understand what I just said, will this kind of problem make more sense and you'll make less mistakes?
Yeah.
Very much, okay. Yes.
So you're saying that standard deviation is the spread? Like,
Yeah, standard deviation is the technical name we give to the idea of spread of data. Yes.
okay.
So that's why I started calling it the spread of the data, just so everybody will be with me with the idea. And we call it standard deviation because math people can't leave well enough alone. We have to, you know.
So when we want to measure if data is, what the spread of data is, then you would find out the standard deviation and then how many of the data points are above that. and
No.
below that.
Standard deviation just tells me how spread out the data is on
Oh,
average, right?
Okay. So you just find
And I can use that. So really, it's exactly what I just said about would we use miles to measure how far people are apart in this room? Of course we wouldn't, because the average distance in this room is on the measure of feet. So standard deviation becomes a natural tick mark on a ruler to measure how far apart things are. And that's of course what z-score does. It says now that we've established the standard deviation as a unit of measurement, how many of those is a data point away from the mean? That's the idea of z-score. So if somebody had a z-score of 2 for height, they are pretty damn tall because they're 2 whole standard deviations above the mean. 1 standard deviation is the average distance people's heights get away from the mean, and this person is 2 of those.
So they're
You with me? So they're relatively tall, yes?
right.
Whereas if somebody else had a z-score of negative 0.1, they're slightly below average. Not a big deal. Yes? You wouldn't look twice at this person, but the 2, you'd go, oh, okay, yes?
Z-score is how big your step is.
No. Standard deviation is how big the step is. Z-score is how many of those steps
Oh,
it
okay.
takes.
How big? How
Sort of like on a ruler, the tick marks are like standard deviation. If I measure the distance, that's z-score.
So this right here, so the z-score.
Yeah. So, I think where we left off last time, I got a little ahead of us on here. So does everybody agree now that, can somebody read this? Well, that's a little evil, Jeff. This says add these up, yes?
Yes.
This whole thing gets replaced by a number. And what was it we got? Yeah, we got 69. You don't plug something in for x, that wouldn't even make any sense, because is x a single value? No, it's all these values.
Yes.
What goes on the bottom here?
11.
Why?
Because
Because n is 12. There's 12 data points, so it's always one less. And we talked about why that made sense last time. And I understand if the talk I have about the concept doesn't make as much sense as I wish it would or you wish it would. There's always 2 levels, the nuts and bolts of doing it and the concept. The more you get the concept, the less mistakes you'll make with the doing it. If you don't get the concept at all, can you still do the nuts and bolts? Yes, you can. But you can make some easy mistakes here.
That's what the concepts was like escape. So why was this 11 again? It was 12.
How many data points?
12.
So n is
Variable base.
what is n? Number of data points. There's 12 of them. So what's n?
And number of data points.
And so here it's what?
12.
12. So n is 12. And what's on the bottom of the formula?
11.
What's on the bottom of the formula?
12.
No. What's on the bottom of the formula?
N minus 1.
Yes, and n is what?
Oh, n minus, okay.
Okay.
Okay, wait. That's
So this will be 69 divided by 12.
But why
minus four.
minus 1 though?
We talked about that last time. So it's, if I want to summarize very quickly, if I take a sample and I take the average, will that, let me ask you this. I
You're
didn't say
starting off from that.
I didn't say it like this last time. If I just take a sample of you guys and I average your ages, will it be the same as the average for everybody? Could it be?
Possibly.
But what would you put money on? Different.
Yeah.
Because if I take a sample, I'm almost invariably gonna just randomly get some younger, some older. You with me?
Right.
Does that make sense?
Yeah.
I would, and I'm a teacher, I would put a lot of money on those 2 being different. Because the probability they're the same is roughly the same as a meteor striking us right now. Okay. That's for sure. So, the n minus 1 is us going, I can look at it 2 different ways. there's one more data point I could have taken that would have made the sample have the exact same average as the population. Does that make sense? And that was a whole thing we did last time. If I have so many data points,
So it's give or take.
one more data point could have made the whole thing become the same as the population. So when we do this, we're saying, for a sample, this is an adjustment for a sample. There's one data point we could have gotten that would have made the mean the same, so I'm gonna calculate this as if I have one less data point than I should. So that's why it's n minus 1 on the bottom. Another way to look at it was, if I take a sample, aren't the people in the sample closer to the average of that sample than they are to the average of the population?
Yes.
If I randomly take a lot of young people, their ages will be closer to their average than the average of everybody. Does that make sense?
Yes.
So on another level, if I divide by a smaller number, that will make the standard deviation bigger and it will approximate the population better. Because any sample will have a smaller standard deviation relative to its own average.
So the more data points you have, you have a larger.
Sorry about that. The easiest way to look at the n minus 1 is as an adjustment, because I just
It's
have
like when you say give or take, like approximately.
sort of. Yeah. It's an adjustment because I just have a sample.
Okay.
That's one immediate way to look at it.
I'm trying to find the why.
Okay. And what do you get when you do this?
6.272.
Yeah, it's like goes forever, yeah. So let me show you something nifty. Okay, 69 divided by 11, you get all that business there, yes? Is a very handy button. I want to take the square root of that. Now, it's not that big of a deal to type all that shit in there, but do not do the square root of a rounded number. I want to do the square root of that. So here's a really cool button to know. Square root, yes, square root of answer. Right above your negative button. So hit second negative. That is the square root of the last thing that was on the screen.
Wait, where's the answer button again?
Above the negative.
Oh, sorry.
There's a minus button and there's a negative button.
What'd you hit first?
So I've got a number on the screen that I want to take the square root of. So I hit square root of answer. So answer is the most immediately accessible memory space. It is the last number that was on the screen. So answer, this always has the last number that was on the screen in it. So the minute I hit enter, what would answer have in it now?
2.5.
Yes. If I hit just answer by itself, answer, it's that number because it always updates to be the last number that was on the screen. Do you see how useful that would be?
Yeah.
You have all this calculation and then you gotta do more shit to the number you just did. It's an answer. That's awesome. I don't have to retype the whole damn number. I can just hit the answer button. Maybe.
Yeah.
Do you have to? No, you can just type the whole damn thing. Every little thing I'm talking about, the lists and the thing I just did, they're all shortcuts. So you can do it the long answer way. That's fine. Yes. Oh, okay. Okay. Do you have this in your calculator? Yes, totally. The formula needs to add these up, yes? And these are in list 3, yes? The formula needs to add these up, and these are all in list 3. So I just need to add the numbers in list 3. So if you wanted to, you could copy these numbers down and then put them one at a time in your calculator, plus, plus, plus. And then you would still get 69. We did the shortcut with the list and the math. You don't have to do that if you don't want to. Does everybody get that? Just gonna show you shortcuts, and then you know the long ass cut. Just add the freaking things. Okay. I like it. Okay. So so what is this again? What is this?
The
69 divided
variance.
It's the variance.
Variance.
So how do we get the standard deviation? Well, I'm telling you here, but square root. And that's why it's kind of nice. The variance has a square on it. It's reminding you, hey, you have the square root again.
Answer.
So we just did that. I'll do it again. So if I do 69 divided by 11, and then do the square root of that, no, Jeff. 2.505. Yes.
I'm sorry, okay. Usually you do that right, you unsquare something, right? You square root it when you square it to unsquare root it.
Well, I mean, not generally. There could be all kinds of reasons we're square rooting something. In this case, we're square rooting it because we squared in the middle.
Yeah, but like, usually when you have, so for example, the s squared, and then you're square rooting it, doesn't that usually cancel off, or that's normal?
Of course it does.
Okay, but, so the s2 is literally.
Which is why if I take the square root of s squared, these cancel and I'm left with s.
But we had to find, oh, never mind.
Don't worry.
Sorry.
So this formula here is a formula for s squared.
Got it.
And that's because I squared stuff. And then when I square root, I'm undoing that.
Got it.
Now, can somebody tell me what that means? Sure. What does it mean?
How many is far away from me?
On average,
For the mean.
every data point got 2.505 away from the mean. Right? Either above or below. Yes? So if I had another set of data where the S was 3, that other data would be more spread out. Yes. So this spread for the quiz, for example, is a little bigger than I would normally expect. And it's because I had 100 and I had some other people down here. So huge spread then in the data, yes. And very quick, I'm sorry, very quickly. I curve the grades, yes?
Yep.
And when I curve grades, I don't just pick the distribution up and move it up. I do this. I shrink the standard. The original standard deviation was 21. So I kind of do, here's A and F, and I kind of do this. I squeeze them a little bit, yes? Okay, I'm sorry, just wanted to let you know. Yes?
I'm sorry, just for clarification, so that example you just said where, how you determine, spread from standard deviation? Like, you said if it was like 3,
Oh.
I missed that.
Whatever the standard deviation is, that's how far every data point got on average from the mean.
Right.
If I had another set of data where the spread was, the standard deviation was 3, it would just be more spread out.
Oh, okay.
Yeah. What if I had a standard deviation of 0,
No spread.
which means the data would look like
Just all.
all the same number?
Yeah.
Yeah. Could I have a negative standard deviation?
No.
I like the of course. That's awesome. So 0 means no spread. What would negative mean? It somehow is like, it's like,
Inverted.
I don't know, we're in some other parallel universe where circles have corners and shit. I don't know. You guys can so there cannot be
Right.
a negative standard deviation. Mathematically, we're freaking squaring and square rooting. That cannot come out negative, yes? You guys with me?
Yes.
Okay. 0 is the smallest it could be, because that means no spread. This I officially call the z-score, yes?
Oh.
The z-score measures, now listen, the z-score measures the number of standard deviations from the mean to a data point. So this is kind of like data point by data point. How far away is it? So if you're on your quiz, your z-score was 1.3, you were 1.3 standard deviations above the mean. This is beautiful. Okay, I'm excited. It doesn't take much. Here, you come here for a second. So let me say what I just said again. If somebody got a z-score of 1.3 for their quiz, yes?
Okay.
Are they relatively happy? Because at least they were above average, yes? Okay. What does that mean again specifically? That would be that their quiz grade was
1.3.
1.3. 1.3 what? 1.3 standard deviations above the mean.
Yeah.
Okay, good. Can you tell me what that score would be? Just do mathematically what we just said in English. I want to start at the mean and I want to go where? I want to start at 66.
Yeah, 3.
and I wanna go up, how many steps?
3.
1.3, and how big is each step? Do it, how big is each step? 18.992, good, yes. I want this to make nothing but sense. If I'm trying to find the data point that is 1.3 steps above the mean, of course that's gonna give it to me. I just translated directly from English to Mathfish. I'm gonna start at the mean, I'm gonna go up 1.3 steps.
So,
And then whatever the shit that is, I don't know. Oh, please somebody save me from this. What is it? 90.6 blah blah blah, so like a 91 roughly. You guys kind of with me?
Yeah.
Okay. Maybe I rounded the z-score. Does that by itself make sense? If you consider standard deviations like steps, questions like that become a lot easier. Yes?
So if it was, you wanna find below, you just subtract it.
If I said somebody had a negative 1.7, I would start at the mean and go down minus 1.7 steps.
So the 1.3 is the step, and the 1.8
No.
is the step size.
This is how big each step is.
Yes.
This is how many steps.
How
So if
many?
I started at the 10 mark, and I took 2 steps each 4 feet big, right? If I start at the 10 mark, and I take 2 steps 4 feet big, where do I end up? Start at the 10 mark, and take 2 steps forward that are 4 feet big.
14.
I end up at the 18 mark, yes? I know, I want everybody with me, I'm sorry, dude, you're good. You guys, does that make physical sense? Of course, it's got to. I start at 10, I take 2 steps that are 4 feet big, and then 18. That's exactly what the shit we just did. If 10 was the average, and the standard deviation was 4, and I take 2 of those steps, I end up at 18. 10 plus 2 times 4. So what is this in symbols? What was 66 for this?
the mean,
The mean. What was this?
just one, the Z bar.
Z. And what was this? Standard deviation. So how do I get to a data point? I start at the mean, and I'm gonna put plus or minus, is that cool?
Yeah.
Start at the mean, go up or down, depending on if the z-score is positive or negative. This many steps. So often in mathematics, you can actually read an equation in English. If I go this many steps away from the mean, I get to a specific data point. That's what that freaking says. Now, here is a little tiny bit of algebra. And in fact, we already did this problem. Let's see if anybody remembers. Can you guys, we sorted it with different symbols. Can you solve this equation for x? Don't freak out. Yes, sorry?
I'm kind of confused because I did it, right?
You
And
did
X-
what, sorry?
I did this,
You
What?
did, sorry.
C, like C.
Oh,
I,
sure.
I started it, so that's pretty much what list 2 is, right? So I put from list 2.
No.
That's where.
Okay. Do I know the mean?
Yeah,
Yes, what's the mean?
6.5.
Do I know the data point that I'm currently interested in?
Oh, 8.
8.
Got it. Okay.
And do I know the standard deviation?
2.5.
0.505.
That's where I was confused. Because I was reading.
So
that.
this will end up telling me how many standard deviations from the mean to that data point. That's what the z-score tells me.
Clear.
So, and then what would this be? 1.5, 15 over 25, that's 5 over, 3 over 5, like 0.6, maybe 0.5 something, 0.59?
5.405.
1.598.
Oh, this is interesting. Okay,
I got 0.5.
what happened to you is if I put in the calculator this, is it gonna give me the right answer?
No. I guess-
It will not, because this calculator understands PEMDAS. Please excuse my dumbass son. Or Giron Tally. You guys got with me? One semester my students came up with, please excuse my deficient algebra skills. They came up with that, I want you to be aware. If you put this in the calculator, what is it gonna do first? It's gonna divide first. What do I want to do last? Okay, so you gotta tell it do that first, calculator. Poor little calculator has no eyeballs. Thank God, it would be weird.
Calculator, but look at that.
I don't want it to have eyeballs. Does that make sense?
Standard
So
deviation.
it's 0.59.
Yes, that sounds better. What does that mean? Is 8 a full step up from the mean? No, it's a roughly 6/10 of a step up. Does that? It's 0.59 of a step above the mean, so you're not even a full step up.
Can you round it or no? This you don't round.
I'll tell you this, z-scores I want, you'll see why later this semester, I want z-scores to 2 places.
Okay.
But if you make them 3, it's not a big deal. Later this semester, we're gonna use a chart where all the z-scores are 2 places, and that's why I want that. Oh, I'm sorry, I'll crowdsource this. So what's the next decimal place after 59? So what should it be if I round it to 2? It's 5988, yes? So that should be 0.6 if I round it, yes?
So you do round this. You can round it.
You can, yes.
Okay.
If you put 0.5988, cheers, that's beautiful. Yeah. Stop for a minute. So if I ask you, in fact, let me just say this. Come back here. Every single test, what is one thing you wish that math people would tell you about a test?
Everything that's on it.
What if I told you one thing that's on it? Would that be better than not telling you anything?
Yes.
Here is a question I'm gonna ask on every damn test this semester. Every test, I'm gonna ask you this question. You ready?
Explain.
What does the z-score tell you? I'm gonna ask you that question. Someday I'll get more than 50% of people getting it right. What does the z-score tell you?
How many steps?
Now be very, when you answer a question like that, you gotta be technical. Steps are cool for talking about things informally. The number of standard deviations from
the mean.
mean to the data point.
Do you have to put it to the data point you're like trying to find or?
It's understood the data point means the one we're interested in, but if you did, you wouldn't be wrong, you'd be fine. You guys with me? I just did what every student wants me to do, and I've told you the answer to a question I will definitely ask you. I could ask it to you like this, just to be very transparent. I could say, what does a z-score of negative 1.39 do? How about a data point? Giving me that data point is, so negative 1.39 z-score. What would that mean? The data point is,
This,
if a data point had a z-score of
Is-
negative 1.39, what would that tell you?
1.39 below.
Yes, that data point is 1.39
standard
standard deviations
from the mean.
from the mean is fine, more specifically, below the mean.
Below the mean, okay. So it's how many standard deviations from the mean to the data point is the answer.
And if I give you a specific number, you don't just say how many, you just say that many. Yes. I love this. Why do I do that? Because z-score kind of controls so much shit at the early stages of statistics. It's just the dominant thing. So we're talking about z-scores now. We're going to sort of take a detour into some other stuff, and then z-score is going to come big. Start in chapter 6. It's going to dominate basically everything else we do after that. So, okay. All right. So last question I put down here. Let me say this. Okay. There's one little thing in section 2.7 that talks about normal distributions. If I go one step down and one step up, so these are z-scores, is that cool?
Okay.
And why did I put a 0 in the middle? If a z-score tells you the number of steps from the mean, what's the mean z-score? What z-score does the mean get?
Oh, 0.
0, because it's 0 away from itself. So 0 z-score in the middle, and I take one step up and one step down. Since it's a normal distribution, there must be 68% of the data in there. And just to be really transparent, it's actually 68.28 or something like that, so we sort of round to make it easy to remember. This is 68% of the data is within 1 standard deviation of the mean.
It's always 68%.
Yes, if it's a normal distribution, if it's a bell curve, there will be exactly, well, 68 point whatever, but still 68% within 1 standard deviation. So real quick, just to give a concrete example, the average height of men in America is 69 inches, with a standard deviation of 2.8. So real quick, can you guys help me? If the mean is 69, I'm going to put that right there, yes?
Okay.
What's 1 step up?
70.
No.
Oh.
How big is each step?
71.8.
71.8. I love it. Is that cool?
Yeah.
Every step is 2.8, yes? What's 1 step down from 69?
67. 66.2.
60, okay, don't worry. So I can say with complete confidence that 68% of American, well, this is for men, right? 68% for American men are between 66.2 inches tall and 71.8 inches. The door back there. I love how I always want to see who turns around. The door back there. Why is it the height that it is?
It's the average.
Not even the average. It's well above average. Because what do you not want to have happen? See you guys later. Right? That would not be good. You get some complaints. So what they do is they establish a door height that works within what they want the room to be, but that only a small percentage will be taller than that.
Got it.
Why do they overbook airplanes? Why do they? You guys know this. Has anyone ever been bumped, or you ever been flying? Has anybody ever been on a plane?
Yeah.
Does anyone want you right now? That's a whole subject. Have you ever heard we're looking for somebody to give up your seat and we'll give you $500? And then you wait like 3 minutes. All right, well we're gonna give you $800. And I always wonder if there's somebody like,
I'm waiting for that.
hit that 1,200 now, do it. Hey guys, maybe, and that's because they overbook flights. Why do they do that?
To make sure they have enough.
They want to make sure they have a full flight, and what happens on average, some people don't show up. You guys with me? So they can kind of control how overbooked they book a flight so that they try to minimize the bad PR they get, but they maximize the profits. You guys see what I'm saying? There's an entire class of statisticians whose job is to do that. Just look at data, control, change the little things in the program, and then kind of see how much overbooked they could be. You guys kind of with me?
Yeah.
It's silly the amount of jobs you're gonna have as a statistician. Okay. Is that okay? Real quick. Oh, what's up? Sorry.
Oh,
You good? What's up?
real quick on that one. Can you just review it real quick?
It's just if I have a normal distribution, 68% of the data is within 1 step of the mean.
Okay.
If they go 1 more step out, there will be 95% of the data. So if I went 1 step up with my heights, this would go up to 74.6, and this would go down to 63.4, I believe. So 95% of American men are between 5'3" and 6'2", 3 roughly, 2.5.
So 2 steps is 95, 1 step 68.
Yep.
Got it. Always.
If it's a normal distribution. If it's not a normal distribution, I have no freaking clue.
How do you check?
With me?
Are you weren't doing that? Is that gonna happen on the quiz?
What do you mean?
Like random.
No, that would be evil because you have no way to know.
Okay.
If I go 1 more step, I get 99.7% of the data. And if I go 1 more step up, just to kind of make this point, this would be 77.4, I believe, and that is 6'5.5". If I'm thinking about this right. Does that sound right, Jeff? Yeah. Okay.
It's 99.79.
No, just 99.7. So, this could show up in the homework in section 2.7. This is called the empirical rule. And it's gonna come back in a big way in chapter 6, but for the moment, they just want you to realize it because it's an immediate application of z-score. So here, the reason I like to ask this kind of question is to have a concrete example to relate to this theoretical thing. Can somebody tell me, what do you think about this data if you have it here in order? Do you think it looks normal?
Yeah.
No, not really, no.
Nope. So let's see. If I put the mean in the middle, what was it again? 6.5?
Yeah.
How big is each step?
2.5.
Yeah, 2.505. So if we go one step up, can somebody tell me what that would be? 9.005. Is that cool? Because the standard deviation is 2.505. And I'm a math guy, so I'm going to be precise. Within a certain level of confidence. If I do 6.5 minus this, that'll be 3.995, I believe. When I told you about these percentages, did I actually have any American men that I had up here that I was measuring their height? No, this is theoretical. This, I can actually go, how many data points are between these two? Can't you just go look at your list? Let me see if I have it sorted, so I'll make it easier. How many data points are between 4 and 9, basically, right? So if you look at your list, I get 9, yes? 9 out of how many total? 12, and 9/12 is 75%. If this was normal, what should that have been? 68. Why is it not surprising we didn't get 68? Because this ain't normal.
So there was 9 data points between out of 12.
Yeah, there's 9 data points that I caught. If I start at the mean and go up and down one step, I catch 9 data points. Do I catch the 2? No. Do I catch the 4s? Yes. Do I catch all the way up to the 9s? Yes.
Yeah.
Do I catch the 10?
No.
No. Okay, so then I got 9 data points in the middle out of 12. Okay. Woo! Okay. And by the way, you did bring this up earlier. Section 2.6 is one like section 1.4. I kind of left it for you to read about, but here's the idea of skewed. Can you guys describe this? What would you say about this?
In the middle.
Bell curve is a normal distribution, correct? You guys ever had taffy before?
Yeah.
Or if you've never had it, do you know what it is? It's really stretchy, yes? What if I grabbed one side of this and I pulled it? Which way am I pulling it right now?
To the right.
Yes, so if I see something that was like this, forgive this poor little, he got hit. Does it look like somebody pulled it to the right? So this is skewed right. So what do you think skewed left is?
To the left.
Okay.
I can control this.
So fine, we're at the point, let's do this. I'm gonna make a formula sheet with you, and then I'm gonna open it up to anything you wanna do. We can do another example, standard deviation, we can do an example from chapter 2, we can make a histogram, we can do whatever the hell you want to. We can do problems from the practice test, problems from homework. Let's do the formula sheet real quick. So, every time we do a formula sheet, you are not allowed to have words on it unless I specifically say a word you can have on it.
Dim.
Now, for my smart asses, you could put at the top formula sheet and you can put your name. That's fine. What I'm saying is you can't say population standard deviation equal. No. So don't make you memorize formulas. I make you recognize formulas. Because I'm an expert. So if you wanted to, if I were you, I might not even do this. But if you wanted to, you could put down the formula for the mean. But you all know how to calculate the mean, yes? this, if I were you, this might freak me out, but you can certainly put the formula for the mean, because it's a formula we talked about. If I were you, I would definitely want the formula for the population variance, yes? You see how it has just n on the bottom? But for a sample, that's when we have to adjust for the poor little sample dude. You guys with me? And of course, if you wanted to, you could have a separate thing that would be the square root of all that. It's completely up to you if you want to put both of these.
Okay, wait a minute.
Yes?
What's the, so that's population, this is sample over here,
Totally. How do I know?
because of the little,
Because of the Greek letter. That's population. Our letter, same.
so.
So don't put next to this pop, because you will lose points on your formula sheet. That sucks, because you can't get those back.
So the top one is for finding,
Yeah, what is this for? Be very specific. Or tell me anything.
damn,
What is this formula for?
Variance.
Variance of a population. What is this for?
Variance of
Variance
sample.
of a sample. This is the standard deviation of a population. Standard deviation of a sample. I like it. Almost exactly the same, just one little adjustment when I have a poor little sample. And then you could put down this here. Let me do this. We've kind of got like a population side and a sample side going on. Might as well keep that going. And earlier, I was about to do something and I think I got just derailed a little bit. This is not the formula sheet right now. Little side note. I think I asked you to do this and somebody asked me something and I got derailed. Can we solve this for x?
Yes.
What's the first thing I could do? What's the worst thing about this?
The fraction.
Stupid s is making a fraction, yes? How do we get x by itself? One more step.
Add x bar.
Isn't that the exact same formula we have on the board from earlier? Of course it is, because it came from what a z-score is, and that came from what a z-score is. So of course the math better agree with what we as humans just did. Because math does what we want it to do. If I had a population one and I did all the same work, I would end up with this. Mu plus z sigma equals x. They both mean the same thing. If I know a z-score and I know the mean and the standard deviation, I can calculate what data point that gets me to. So you can add that to your formula sheets now. Same formula, just different symbols if I have a population or a sample, right? They're exactly the same formula. Does anyone think you should have any more formulas besides the ones we put down? How about class width?
Yeah.
No, you can't. Sorry, gotta set you up for that. You have to know the formula for class width. What is the formula for class width?
Range over.
Range
I
divided
minus
by,
slope.
yeah, I minus slope, divided by
Oh,
divided by.
number of classes.
Number of classes.
Number of classes,
Which is 5 to 10.
which is 5 to 10, you just pick one.
I pick 5 to 10.
And what did I tell you guys? You're basically gonna pick either,
5 or 6.
because we're gonna have such small samples. I'm not gonna give you 800 data points.
So,
One, because that would be mean, two, because I don't wanna do that many. Huh?
so if the range was like 20 through 20 divided by 5, right? So then you have 5, you go up by 5s? Is that what that means?
If I gotta go, what do you say, from what to what?
So,
The data goes from,
say, can we do it on, I'm not a visual person.
Sure.
So sorry.
alright, real quick.
Okay.
Any other suggestions on a formula you want on here? So really wanna make this clear. These are all the formulas you can have. You cannot have any words on here besides formula sheet with your name or whatever, yes? And you're gonna turn it in with your test. And I always get somebody that loses points on the formula sheet. You can't have more than other people are allowed to have, that's not fair. So this is exactly what your formula sheet can look like. Through the whole semester, you can just add the formulas to it that we find. Yes? Okay. Yes,
Can we put the formula for z-score?
we did.
Oh, we did? Oh, I didn't see that. Sorry.
You're good, you're good. Okay, so let me come back. Oh yeah, okay. So let me ask you this. Huh?
No.
What's up, sorry?
I said it was copying, I thought you were
Oh, I'm
taking
sorry,
it.
go ahead. What do you guys think, class width? Okay, no, they said so. Because I told them a minute ago.
Can you pull it down a little?
Okay. So the second one,
Yeah?
okay,
Second,
the first one's the mean,
for a,
population per sample.
yeah.
And
And like I
then-
said, if I were some of you guys, I wouldn't even put these down, because you guys know how to calculate an average, yes?
Yeah.
But I wanted to put this down here because they are official formulas that we could put down if you wanted to. I know how to do an average, so I don't need this yet.
And then the second one is.
You just
the
told me.
Variation.
Oh, down here, the third one,
Variance
variance of a
population.
population.
Of sample,
Variance of a sample, standard deviation of population, standard deviation of sample, yeah.
variance and standard deviation. And then those are how many steps you're taking.
Yeah, the z-score measures how many steps from the mean to a data point.
Yeah, standard deviation, okay, cool, sorry.
So when we, write these down as we go, okay. So everybody got these?
Yes.
Alright, so your question is, if I had data starting at like 12, 14, and it went up to 73, let's say, yes?
Okay. So,
So do you guys wanna use 5 or 6 classes? You tell me.
5.
5, okay. How do I calculate the class width?
So you do high minus low.
High minus low,
So 73 minus 12.
divided by 5.
Okay.
And what do you get?
73 minus 12.2.
Now, one of you guys, tiers for a couple reasons. You didn't round your decimal up and you just used the decimal you got. You don't have to do that to yourself. What can I do here?
13.
13. Then I used 13. So what would my first class look, what would my first 2 classes look like? Thank you. I start at 12. Oh, shit.
Sorry.
Oh, no. Oh, okay, okay. It's not that big of a deal.
12 to 24.
Yeah, because where would the next class start here?
25.
Because it has to be 13 apart, yes?
Got it.
So now, if I put a little something like this, some of you guys might see on your test, it says 9, 9, 8, 8, 9, like your width wasn't consistent. So how do you see width when you do this the textbook method? You see it this way.
Got
Because if they're supposed to be 13 apart, and this one starts at 12, this one's better start at 25, yes? If I also put a 25 here, that would make no sense, because then where would 25 go?
it. Yeah.
Okay.
And you need them to overlap.
Is that cool?
That answers my question.
And again, class width is a physical idea. It's physical. How far do I have to go divided by how big each step, how many steps I want to take, yes?
Yeah.
If I do that calculation, it'll tell me how big each plank, or, like I was talking about the wood planks, has to be to cover that, yes? And I round up so I overcover instead of undercover. Okay. Yes?
On homework 1.4, it was asking about,
Oh, yeah. The first problem.
Yeah.
So they give you a situation and they say use key terms to. So you had to read 1.4 and you get terms like response variable, explanatory variable. If you read the section,
Okay.
you have to use the terminology from section 1.4.
Okay.
Yeah. So I'll just tell you this: you must do the homework. Those terms are important, but they will become much more important if you go on to do. I don't know if any of you guys are going to do like stats. In stats, they have like a data research methods course that builds on what you learn here, but then you start to understand how to design an experiment, and then stuff like that becomes very important. Right? Like double blind means the patient doesn't know if they're getting a placebo or not, and I don't know if they got a placebo or not, and that makes bias less likely to be introduced.
But then how would we, okay, just weird question, but how would you know? If you don't know and I don't know,
Oh.
how would we know?
You have a system that records it. So maybe you have like vials that are green, blue. We don't know what they are, but the system knows. So when we put the data in, it knows which person what, and if they got a placebo or not. You with me? So you have a third entity, and normally it's a unfeeling, unthinking thing. Computer system. Yeah.
Okay.
I know. When you first hear it, you're like,
I'm like,
this shit knows.
then how are we even tracking it?
They just
That's
they
the,
hope.
Okay.
He uses it.
So, just so you understand, it is now completely wide open. We could do whatever kind of problem you want to. We could do an example of a problem. We could do a specific problem. I can restate definitions. I can anything you want to do. And some of you guys are like, I want to leave. I want to leave now, Jeff. It's college. You can do that too.
I don't wanna leave.
Okay. Yeah.
So 6.5 is the mean, right? So how do you, what is the next step of filling this data?
Where are your X's?
So right here. L1.
Good. So you want L2 to be L1. 1 to Lmax is minus the mean, which is 6.5.
And that does, well, that's crazy how that's the whole thing. That's why I was
Well,
like,
cost
I was,
doesn't-
I was, cause I was like, I couldn't do, I was like looking at it and I was like, okay, this makes, I overcomplicate things.
Oh, yeah.
I do the same thing.
That is easy to do. Overcome.
Okay, they're not.
Things should not be too complicated yet. They're not complicated, they're just different. You're not used to this. The math isn't hard, it's just in the middle of weird stuff.
And then L3 would be squared. So I would
Square L2, go up to L3.
So like
L3
Until that second two, square, second two for L2. See above 2, L2. Above 2, the number 2 is L2, and then square. There's a square
I'm
bracket.
sorry,
Square bracket. Enter.
so when you have class with like he just range, you just might as well open the number.
Oh yeah, I'm sorry. I'll go ahead and give you guys the answer key.
So if you chose 5, so the 77 thank you is the highest in this data set, and 60 is the lowest. So then when you divide that by your chosen number of classes, which is 5.
Oh yeah,
Divide
you're
it.
working these together, right?
Always remember because it's better to have open classes until they get under coverage. So this 3 program will be 4.
This is a lot.
And then when you go over to make your table, this is what you want to see, so don't skip this stuff very important. So you start with your classes, you just start with the lowest number, that's always going to be the start of your first class. And then the start of your next class is going to be your class with the 4. So this 60 plus 4 is 64.
Yeah.
Go by 4.
This should go by 4s. But to find the other end of your class for each class,
Just don't change
it's going to
your
be, and this is a formula, just keep in mind, it's going to be just add 4, so it's going to be add the class with minus 7. So for this case, it's going to be 60 plus 4 minus 7.
Look at all my beautiful writing you guys got.
Oh my god.
Yeah.
I thought I was gonna catch on.
Talk about a low bar. So,
Oh, I need another one.
first.
No.
We need one more.
oh, I'm sorry.
Yeah, I was worried that he's like, it's like, there's a certain order of things.
So guys, this one I just ran out of room, so I wanted to do this one together. That was the one about creating the box plot with the data. So I've already got it in order here, so that should make it quicker. So let's see. So this is problem number 1. I'm pretty sure most of you probably feel comfortable to put this in the your calculator, sort it, yes? That's all you really need to be able to make a box plot is you need the data sorted. Can somebody remind me what the 5-number summary is? So it's
Oh yeah.
let's see, 5-number summary is low. Q1, Q2, Q3, Q7, no, high, it's good. So what's the lowest data point?
29.
Holy shit, what's the highest data point?
63.
Sweet, so 2 are gimmies. How do I get Q1?
25% of 15.
25% of, and there were 15 instances?
Yeah.
So this is step 1. What's 0.25 times 15?
3.7.
Yes, and what does that mean? What do I do?
4. Which is 40.
Now the answer is not 4, correct? That tells me where the answer is. You go 1, I get 40. So the data point of 40 has 25% of the other data's points below it.
Got it.
And then they each work the same way. How do I do Q2? What's another name for Q2?
50%.
P50 and also the median. So I would do 50% of 15. What's half of 15?
7.5.
You guys okay? I'm doing a little fast, but.
You're good.
So Q2 would be the 8th number. 8th number of the world. And so if you go down, I get 45, is that right? And then Q3, I could do same shit. I could do 75% blah, blah, blah. Or I could just go, oh, I stepped 4 in from the bottom for Q1. I could step 4 in, 1, 2, 3, 4 from the top for Q3. Jumbo! Again, I could do 75% of 15 and do all the same work. Or since I stepped 4 in from the bottom for Q1, I stepped 4 in from the top for Q3. Because they're symmetric boogie work, yes.
The IQR is the third minus the first.
Yeah, Q3 minus Q1.
Alright. So it's 12 in this.
Oh, I don't.
I don't see it on here, but I could be crazy.
It's done. I don't answer. So how do I make the box plot? What do I do? How do I make the box plot? I'm gonna make a mistake. You ready? I'm making the box plot, yeah. I'm making the box plot, yeah. Here I go. What have I done wrong? What is my scale? What's this? What's this? What the shit? Alright. Bad, yes? And I really love some of you guys are looking at that like this. Perfect. That should make no sense. That should be like nails on a chalkboard. The scale has to be consistent to make sense. I have to be able to go from 29 to 63. So what's a decent scale for that? Yeah, 5 seems to be. Let's do 10 just to make it different. So let's go 25, yeah, let's make it really different. 25, 35, 45, 55, sure, 5, okay. And then I just put a number, and then I put a line above each value. So 29, become a 5. 29, 40, 45, 52, 63, just kind of guesstimating. Box the middle, whiskers for the outsides. Now real quick, a couple of homework problems. They had a box plot that looked like this maybe. And the nice thing they did in the homework is they would dot a line there, like that.
Yeah.
What that meant is Q1 and Q2 were the same, which are completely possible if I have a lot of repeats in the middle of my data, yes? So they do like a little dotted line to show you what's overlapping. Okay, maybe. If you've done the homework, you know what I'm talking about. Is that okay? I just didn't have that on the key, so I wanted to do that with you. Yeah. So real quick, that looks pretty decently symmetric, doesn't it? Just from my box plot? No?
Yeah.
You're still a jump. And then if I look back at the histogram, what's that look like?
Good.
That looks pretty decently symmetric, right? In fact, it looks very roughly normal, yeah? Is it perfectly normal? No. Is it roughly normal? Yes. And I can relate to that. Not roughly normal. Yes.
For standard deviations above the mean, where's the 98 and what's the 13 again? Like on the
98?
page that you did.
98?
Yeah, you did 98 plus like 1.24, which is the standard deviation.
Oh, down here.
Yeah.
I'm sorry. So the formula is, so I'm trying to find the price. I'm trying to find the data point, right?
Right.
So the formula is, the data point is, start at the mean and go so many steps, yes? Can't remember, this is a population, that's a sample, so this will be S. So I took the mean, started the mean,
Plus
the mean was 98, and it went up, because it's above, 1.24 steps.
Why is it 13?
Because the step size is 13. Standard deviation is 13.
Oh, that's, oh my gosh, yeah, I'm an idiot. That was right.
No, you're not. Stop it.
Oh, that makes more sense.
So the first problem says 2 standard deviations below. So of course I'm going to start mean and go minus 2 steps.
So the
I know,
1.24
shit,
is
then I get that
how many steps?
Yeah, because it tells me I want to go 1.24 standard deviations. So I
Above.
want to go 1.24 13ths
Okay.
above the mean. Yeah. So like,
Slightly
oh, I even pointed out. Yeah, yeah. That's a very, very common.
and
Look at past Jeff doing all kinds of shit. Yes.
On for D or for the range for question 1,
Yes.
or I mean the mean, I got
Oh, mean.
I got 40.3 like going on forever. I don't
Uh-oh.
know how I got that. Oh, I
Okay.
might have done the whole thing that I did earlier where I divided it, like I added and divided at the same time.
Ooh. Okay.
I think that's my problem.
Yeah, get the sum of them first, and then divide. Yeah.
Oh, wait.
you numbered them wrong.
No? Oh.
So we aren't doing the whole like frequency, right? Relative frequency thing anymore, right? Now we're moving on to this.
No, here, look.
Throw me off of it.
Oh, it got cut off here. I think. Shoot. My poor little classes got cut off here. I'm sorry, but it started at 29, and my class width was 7, so this would be 36. Can you guys see that? It got cut off by my printer. So yeah, there's my frequency distribution. There's my histogram. Yeah. Yes.
When it comes to the standard deviation chart, when I put it in my calculator, how do you, I noticed the way that you round, is that standard for the way that you round? Like when it's, did I do something wrong? Cause it's needed to be rounded, right?
Oh yeah, because our mean was this. Now here, let me show you. Let me show you. Let me show you.
Oh, okay, so you did do that.
Let me show you something. Let me show you 2 things. Does anyone still have this data in your calculator from that one problem? Alright, let me show you this alternate. I said this earlier, but then I forgot to show you. If you hit stat, edit would be where I put data in, correct? Where do you think I'd go if I want to make the calculator calculate something based on my data?
Calc.
Holy shit. And then I want it to calculate one variable statistics. If I hit enter, some of you guys have this show up. If you have this show up, you want your list to be list 1. I don't have a frequency list, so clear that. If you do 1 bar stats and it just says 1 bar stats and that's all it says, hit enter because it defaults to list 1. So watch what happens. Does this look familiar at all? Does anything up there look familiar?
Oh,
Anything?
X bar mean, some.
Wasn't our mean 6.5?
Yeah, that's great.
What was our standard deviation? Now, look, real quick. Is this calculator smart? It's the dumbest thing in existence. It's dumb. It don't know shit. It does stuff. It don't know shit. Yes? Look at what it gives me. What are these two? And the little X is just telling me if I had a list 2, it would have Y's there. It's just trying to identify if it's X, Y, if I have one more list of data. What is this one? Population standard deviation. What's this one? We as humans have to pick the right one. For that problem we did, wasn't that a sample of quiz grades? So I better freaking pick this one. And isn't that the number we got earlier that we calculated? So I often have students that after I show that, they say, well, why the shit did we do all that work? Because, if you use the calculator, it's going to pass the course and you're going to retake. That's my quick answer for that. So you got to do it, but I want to show you, you have a way to check your work. You can check your work if you do this. So is it currently imperative you know how to do this? No. If you want to check your work, feel free. Now watch this. If you scroll down, what are the last 5 things it tells me? 5-number summary, yeah. So you can double check your 5-number summary. Minimum is low, maximum is high, Q1, Q2, Q3, that's the 5-number summary. So, and again, this is for the data from the quizzes, from the worksheet from earlier. I didn't put this data in, yes? I love it. Okay. So if there's something you want to ask, but it's something I've already discussed, ask. I don't care. Especially today. Today is review. If there's something I've talked about 7 times, and you're like, I need this man to say this one more damn time.
I feel like this
Ask.
core thing is so like so this is asking for the sum of this of all these data points, right?
Sure. Yes.
So it came out to 0.
Yes, it will always come out to 0. That is why we had to kill the negatives, and that's why we squared it, because that makes everything positive.
Okay.
Yeah.
So I was like, okay, is that right? I was like,
Yes, that's a quick check you could do. Is that x minus x bar
balances.
better be 0 because the mean has equal, negative, equal stuff above and below.
Okay.
Yeah.
So like if I got something else there, I know I messed up somewhere.
I mean, you might get something else if you rounded.
QR is
Yeah.
12, right?
And then what was the? So basically. Okay, so if we want to move to the next step, after this one's at the end, -11, so this would be the next step, right? So I would take-
Well, once you sum these up, that goes on top.
69.
Yes, you come to 69. The
Minus
sum
11.
of these is 69, and then you divide by 11.
Okay.
So if you had second motor, then you can get out of your list. Yeah, now you can do stuff. Yes.
What are you trying to say on number 5? I was just trying to
Housing cost?
there you go.
Oh, so he went, okay,
Huh?
that was the
Like
difference.
outliers at extreme highest
He went
would
3.
blank.
Skew the mean, yeah.
Skew?
Skew, which would, like pull it up towards it. Yeah.
I think I got this.
So the example we did with the CEO, the average of the data was pulled in the direction of the CEO's salary, it was skewed in that direction, yeah. So where would I want to use the median in any situation where I have extreme values? Because then it wouldn't be affected by those. And that's why we did that example about salaries at a company, yeah. Or housing prices in La Jolla, or in the region, yeah, yes.
So for yours, for your variance, you left your sum of anyways, you left it to 1029.333.
That's what I wrote, but in the calculator I just used the whole thing.
Okay.
Yeah, so I didn't round until I got to the end.
Okay. So when we write it, do you want us to always go to the 3 decimal places or?
Yeah, standard deviation has to be at least. Standard deviation has to be at least 3 decimal places.
Oh no, I mean like when the variance part. So you wrote 1029.333.
Sure.
You always want us to round that much or that far.
So I want to show you something real quick, because I think you asked this question earlier about the mean, right? So when I go in my list, I could actually put here, how do I list? Like I could say list 1 minus 685 divided by 15. Do you see what I mean? And then it will give me exact answers. Now, of course, I don't have the right dating, but if I put in the first spot 29, I'll show you. Do you see how I gotta do this again. List 1 minus 685 divided by 15. See the first one. So I can put the full number into the calculator. Yes?
Yeah.
Okay, and when I write it down, I can round it. So I added these up. I can write down the rounded thing, but in the calculator, I can use the entire number. Yeah. Okay. I just think, I don't need anybody to ever write like 18 decimal places or something.
No, because when I was doing mine, I did 109.33. So I was like, oh, do you want us to do an extra? So
Oh,
that's what I
as
was
long as in your calculator you're not rounding.
Okay.
Yeah.
That's all.
Yes.
Thank you.
Could you explain why in the bar graph you go down by 0.5 and go up by, can you shift it by 0.5 so they're all touching?
Does anyone know? So, in a histogram, not a bar graph, in a histogram, can I have gaps?
No.
No, hell no. So, do you see how, this is 29 to 35, this is 36 to 42. If I did 29 to 35, and then 36, I'm gonna have a gap here, aren't I? Okay, so if I go down by a half and up by a half,
So you're overcompensating?
not overcompensating, perfectly compensating. Because wouldn't 35 go up to 35.5? Wouldn't 36 go down to 35.5? When they then not have a gap between them? So you can't see the class width between the numbers in the classes if you do it the textbook way. But once you do the limits, once you do the up and down by half, you can.
Thank you.
Sure.
So, I know we just talked about this, so when I got 69, I'm gonna square 69, right? So I did that, right?
Yeah.
So 6.2,
Yeah.
so it would be 6.2.
That's S squared.
So
And
that's
then you take a
S.
square root to get S.
So I square root that.
Yeah, that's S squared, right? That's the formula for S squared.
So I'm looking at this like anime, I'm reading this right.
Oh.
So this answer, so this is, so
The
S2.
formula you did gives you S squared.
So that's 6.2.
Yes, 6.2727.
Cause I just, that's what. So that's, okay, that's what I'm saying, I get confused when I don't know, cause I got the answer and I understand how I got the
Yeah,
answer.
And then you take a square root, so you can get.
So basically, so this S2, so do the standard
S squared.
deviation, so S squared, sorry. I just read S Spanish, so I keep thinking, I see
Oh,
S,
yeah.
S2. So S squared equals, so I.
6.2727.
So standard deviation, so that's the
S.
S, the steps,
Sure, how big each,
each step is.
yeah.
And so the.
If you know S squared, how do you get S?
Variance.
Take a square root.
The math is
Yeah, S squared is
Variance.
variance, that's the name we give it. Yeah.
My G was his F. I will say this.
So I would take the 6.2 squared,
Square root it
square root
to
it.
kill the square. Yeah.
So the root,
Yeah, if I said X squared is 9, what's X? 3. It's like I'm saying, what do I square to get 9? What positive number do I square to get 9?
so basically I could do like this in the calculator, just do square, square root,
And then the
answer.
answer, yes. Kabam.
Oh, okay, that's what I was trying to do.
Alright.
We square root it, we don't have to write, positive or negative.
Hell no.
And that's the standard
Hell
deviation.
For
no.
this one?
So guys, real quick.
How do you get this number again?
And I'm sorry, I don't mean to point you out because I say that because it's a general
Okay,
misunderstanding.
here.
Guys, real quick, little algebra. If I said x squared equals 9, what's x? 4? Yes. If I take square root, I have to put a plus or minus. On this problem, I know s is positive, yeah? So I don't have to put a square root. So if I have s squared is 9 and I square root, why do I not put a plus or minus? Because I know it's got to be positive. Yeah.
And this one, how do you get
Sure.
here?
So what sections are we supposed to have done for all of the
Yeah,
test?
two, no.
Up to 2.
No, dude. All right, guys. What do you guys think? What do you need to have turned in on Tuesday? All of it. Up to what? 2.7. Yeah. I mean, again,
So much numbers.
I understand. So last time we took a quiz that went up through 2. So you definitely should have had up through 2 done then, yes? And you should be just continuously working on that homework. Now, I will say this, I don't know if I said this yet. If it is test time coming and you're like working the whole weekend, and you're like, I ain't got enough time, do not leave entire sections of homework undone. Stop doing every homework problem I assign, start doing every other one. Am I saying I'm gonna give you full credit for that? No. Am I saying you wanna be ready for the freaking test? Yes. So this is a part of making homework your own. Yes? So real quick, I told you a story, my little story, uphill both ways. I had 3 jobs in college. Did I tell you?
Yeah.
No? So I had 3 jobs in college. I did not finish a lot of homework. It was physically impossible for me to do it, yes? I was paying my own damn way through college and university. I'm not saying that to be like, ooh, look at me. I'm just saying that's reality for a lot of us. So I physically couldn't do the homework. There's no way. So I just did enough of it. I did some out of every section, and I turned that shit in, and they were like, what the hell? And I'm like, shut up. And then I kicked ass on the test. And so they made homework worse so much that that's why I had nifty, I always say my report card had personality, right? But I personally knew I knew the shit. You with me? It's just that there was no way in hell I could do all the homework. There's no way. So what I'm trying to tell you guys is, if you're like, God damn, this guy gives so much homework, because you don't have a lot of time, make sure you get practice from every frickin' section, yes? Because I have students come in and they left something blank, and I'm like, what are you gonna do? Like, I didn't do anything out of the last 3 sections. I'm like, well, that's not smart. Do something. Give it to me. I'm gonna say, finish this, and you're gonna say, oh, that's good, Jeff. Is that, you guys with me? The heaviest weighted thing in here are the tests and the fun. Right? Yes.
So like, if we turned it in and it wasn't completed and you like mark it as incomplete, we have to the final to turn it in, right? To return
Yes, you have until the final exam to finish or correct as much homework as you can. Yes. Yes.
Could I have the formula sheet? Just take a look at it real quick.
Sure.
Yeah. I get what you're saying.
No. We needed that. I'll try.
So 8 would be the.
Anybody else not get their quiz back yet?
But I finished the mean is 6.5.
Yeah.
Obviously,
So the homework is due next Tuesday on the first test. And you don't have to finish it. So like for yours, it's just a couple problems. Turn it in, no mark it as.
Yeah, we just wrapped it
Like,
up.
no grade was there, but no, you don't have to put final to turn it in. So just turn it in. So don't, he's saying just don't skip and don't like get to 2.1 like I don't have the time, so I'm not gonna do it. I'm not gonna turn 2.1. He said just turn it in. It's like one question. And then from each section, turn that in. Even if it's incomplete, you have to write on it. So just turn something in.
Anybody
like,
else
your
not get
understanding.
their quiz back? I have so many people not.
He's so worried. Well, we're probably too far. Oh my God. We're literally forced to
Basically,
speak out
this
every
one,
single the meaning of everything.
I would say
He's trying to get us to understand the concept, like what we're doing.
Minus the mean.
And it's in order for you to write, like you're
And then
gonna
divide
write
that
like
by
a sentence. Like,
Yes. Oh, 22 is 20. And that's why it did that. Because you always have to move it twice over. Yeah, so you can always give yourself that extra space so you can visually see it.
Yeah. Like a couple. I was like, why are you?
So guys, when is quiz 1 and quiz 2, when are the corrections due? On the day of the test. Can you turn it in after that?
No.
Of course you can. You can turn in quiz 1 corrections on the day of the final exam. And if you get enough of them right, you might get a point, right? But because it's very late, everything can be turned in late for some credit. You with me? Can you turn in chapter 1 homework on the day of the final?
Yes.
Yes. Will you get full credit?
No.
Ain't no way in hell. Will you get more than 0? Yes. Okay. So normally, if you turn a lot of homework in, like late, that'll hurt you. If you turn in one piece of homework very late, that'll hurt you. If you turn in some of the homework like the next day after the test, I might not even worry about it. It's not like a ton of stuff. You kind of with me? I'm trying to force you. Everything I do is to trick you into doing what you need to do well. Basically everything. Yes, yes.
And then from now on, like, give you a separate piece of paper per section.
No, what do you mean? It's fine.
Like this is fine.
Yeah, totally.
Just want to label it over.
Yes. Yes. And also, very quickly, a really silly thing. Is Cardi B still a thing? You guys know Cardi B?
Almost out.
Alright. Cardi B is a singer. Is Cardi B in this class? If Cardi B was in this class, could they put Cardi B on their homework? Yes.
Yeah.
So every other person in here better put your whole last name. Don't be telling me no, John H. It just helps. It's just a little annoying. Not a big deal, but just put your whole name. Yes.
So, I got 5.98.
Yeah. That's what we got. And then we rounded it to 0.60.
0.60. So you always round, so you round up.
Well, I mean, you round. So if you got 0.5943, you could round it to 0.59. Right? Because rounding depends on what the next place is.
Also, I'm moving the
So
decimal.
either leave it 59 or move it up to 60. Since the next number was an 8, you move it up to 60.
So I'm not moving the decimal point.
Of course you're not, because that would change the number.
Ah,
So maybe just
get
round
it.
So you wouldn't say 6 is roughly 0.59. That doesn't make any sense. But 0.6 is roughly 0.59. That makes sense.
0.6. And then that shows you what. I got, so this is the formula, right?
Yeah, that'll tell you how many standard deviations it would take to get the means of that data point. So it's not even a full standard deviation away.
So
No, like, can you?
the mean is 6.5, and the standard deviation from that is 0.6.
The number of standard deviations
Number of standard deviations.
from that is 0.6 to get you the data point. Yeah. So guys, remind me, what's the z-score tell you?
So, okay, I know, I was thinking, because this right here.
From the mean to the
Yeah,
data.
read the chapter, it's short,
So this
but
is how
you didn't
the
really go
standard
over it, 'cause it's not that
deviation is from
important.
6.5 to 8.
Yes.
And then.
So,
this
practice test, if you didn't do it, you don't have to. Yes? Don't turn it into me, holy shit, I got enough paper, I gave you the answer key, so I don't need to see it. If you don't wanna do any of it, don't. Focus on homework, that's fantastic, that's the number one best way. I give you the practice test so at least you can see how I like to ask questions and so forth. And the worst thing to do is to not do the practice test, but to stare at the answer key and go, yeah. Uh-huh. I would have done that. Because then you're building false confidence, right? So the first couple times I taught, I had students, and here's the other thing. I had a student tell me, I did your practice test, I did every problem like 5 times. And then I made a D on your test. I'm like, well, yeah, because you knew those problems. I'm not going to give you those problems. So if you do the practice test, maybe do them at most twice. If you do it any more, you're knowing that problem. You aren't knowing the general idea. Does that make sense? So study, study, study. Do this. Anything you get wrong, go back and focus on that. Yes? That's how you can use this as a study guide. Maybe. So don't get too excited. Test ain't gonna be this. I have had colleagues that made their actual test the same as their practice test. And thankfully they're retired, so.
But he kind of went over it.
Because you're all like, who's that?
The
They're
rubric
gone.
he showed
Too
you,
bad.
the one that he really didn't go over was like screw to the right field. He just went over it. You know, the little drawing that I had you do for me. Because I suck.
If you have a question, feel free. Yes? Get that to me, stop looking.
Yeah, hell yeah. I completely.
Nothing? You only worry about that stuff?
I got that right. Okay. Can I have an extra practice test? Do you have one?
Oh, yeah.
You don't.
Here.
Thank you.
Sure.
Oh, okay.
By the way, some of you guys are looking at the bottom. If you feel ready for the test, you can leave. I'm not gonna write your name down and say, here, you should go. If you're ready and you don't wanna just sit here and stare at me, then go. And come back next week. That's fine. If you have questions, what I love is a lot of people just are hanging out and they're like, I'm just, in case anybody has questions. Always asking questions. So. I have a feeling not a lot of people might agree with that.
Jeff, isn't it a little high here, so a little too?
I agree with you, but I always run forms, so. Huh? Yeah, I know, this guy right here.
It's a perfect nap time temperature.
Kelsey loves it.
Oh, my kids.
Nap time.
It's just a clarifying question. For my scout, I should have done the half step down, half step up, right?
Yes.
Okay.
Yes.
After you went over it, I was like, oh, that's where.
Ah.
Okay.
Jewel, are you doing okay with, catching up and such?
Do you have office hours tomorrow?
No. Fridays, no. Next day I'm gonna be like up north at a conference all day, so I couldn't even be here if I wanted to.
Your next one is Monday, right?
Monday, yeah.
Okay, at like 5.
Did you see the office hours up in Canvas?
Yeah.
Yeah,
I was
okay.
just wondering. That's it. I was just wondering.
Thank you.
Because I wanted to just talk about everything. I wanted to make sure, like, I understand.
Well, I mean, I've got office hours today, but like right after class, I gotta run off campus and go to an appointment. But I'm back on campus like later. I teach a 5:30 class. So I'm in there at 5. So, understood.
When do you get off today?
Huh?
When do you get off today?
Well, I was gonna go to. After
Oh, right. Okay, can you real quick explain to me?
Oh. So you median instead of mean. So housing costs, definitely. We talked about that. Because the extreme stuff like in La Jolla would drag the average up higher than the majority of the houses. So the median would be more accurate. We did an example of the 3 employees with the CEO. So the CEO, if I included his income, it brings the average way up above.
Right.
So the median is more accurate. So basically, anytime we have outliers in our data, we'd rather use the median because it's not affected by outliers.
Okay.
Thank you.
I have a question about this procedure.
Yeah.
You have
Okay, here's the issue.
Somewhere near.
The sample has to be a group that they picked from the population. So this can't be a group they picked because, how do I say this? So what group of things or people did they study? Not all of them. The 181. So this is the sample. Where did they pick that sample from? All the infants approved, that's the population. Does that make sense? So the percentage, my sample has to be bigger than that because that's the only way I can calculate a percentage. If I only had the kids, like if I was trying to, if I was trying to study how many people like lemon, and my sample was everybody who likes lemon, I'd always get 100%, right? Okay, all right. So you can't say, yeah, you're good.
Yeah.
Okay.
But I want to say I'm not concerned at the same time.
So for my population, is this okay that I wrote this?
All phones, yeah, sure.
Okay, and then I didn't know it was Grossmont, so that's why I didn't put Gross. But
Well, I think on the answer key, I changed
oh,
the wording and I forgot, I caught it in a few places.
This is where I was at.
This is an answer key from a few years ago.
yeah.
And since then I've changed it. So on here I said Park Rosemont specifically, but
Raise your explanation.
yeah, this would just be all students.
Ask why.
Yeah, I kind of meant Grossmont, but you're fine. If I didn't say it, then there's no way you could know it. So just all students, yeah.
And then the last, oh yeah, for, it is not information for the discrete, because you can get it right, but it's like, it should be wrong in the test.
Yeah, here's the problem.
Yeah.
The key for this one is as listed.
Oh.
So gas being listed as this wouldn't make sense.
Okay.
And that's why it's discrete. The actual numbers you see, now what is it in reality could be different. In fact, they more than likely marked it up. Right? But, continuous,
There's just so many steps.
weight community value and continuum. Yeah, good, sure. Okay.
Thank you.
Yeah.
So this one? How do we do the histogram? Like from these numbers? How do we get?
Oh, so your height is based on the percentages.
No, it's manic.
So the first bar, we go from here to here, and it should be up
Because you're
to 6.
constantly looking, you're going through different things.
No, but my question is like, I remember how we got these numbers.
Oh.
So these,
You go down a half and up a half. So down a half, up a half.
It's like,
And what was your class with?
I don't know if you're gonna
Did you see how that's 4?
Because originally we wanted to do, I wanted to.
Right? 4? So once you get the first one, you can just keep adding 4 because that's how wide each class is supposed to be.
and then this one doesn't really matter.
Well, you base this to make sure that you get up as high as the highest.
I ended up here
Where'd it go?
because
The
I
highest
wanted to-
percentage.
Okay.
So don't always go up to 100, just go up far enough so the highest percentage has a place to go.
Yeah, but then,
And then these, since we made them like this, they'll be touching.
I like to at least put.
They have to be.
but
Yeah.
the odds are
Gap should mean empty classes. And did you have any empty classes? No. There should be no gaps.
just specific. So I just do it because I don't do the program. I'm not good at this.
Oh, so real quick,
It's like this.
it should be 47 points.
Okay, that's like too much. I do that.
53 points. And then you can see, and then you just keep adding 6.
And then for the side.
So I ended
Yeah,
up
you do it
here.
based on, you can make these percentages, so, you know, and you have to go up to 23.3%. Yeah. So you wanna make a scale so that maybe this is 25 of course, so you have a case for where you want to go.
Sounds good.
Seems more substantial.
Oh, that and surprisingly came
Um,
Oh, yeah. Your math was.
Oh, I see, so this has to be these numbers.
Didn't get there from the.
You created a frequency, okay, yeah, frequency distribution, so these are the frequencies,
Everybody
yes.
knows let me go.
That's not, yeah, that's not the frequency. I want a relative frequency. I need these numbers to be.
I would say I
Now, what's funny is the shape won't change much,
like no.
You like the concepts, right?
it's still relative to but this scale should be percentages.
I know that makes sense. It's relative, but like
Yeah, yeah.
no one that lives in Skyline.
Uh,